What's going on, everyone? Welcome back. Okay, so in this episode, we are now getting into setting expressions and images onto our different character types. That would be our single layer and multi-layer sprite characters and the sprite sheet characters as well. And so it's going to be a couple of tasks that we have to do to make this work. The first of which is we need to define what a layer is on each of these characters. Well, we know that a layer is going to be whatever these image renderers are. Each renderer is going to represent a layer, and by changing the image that's applied on that layer, we can change how the character looks. And for our sprite sheet character, be just the same, but we would go through and select one of these sprites that we ripped in an earlier episode and split them up, and then grab whichever one it is and apply it to whatever layer we're trying to place it on. So let's go ahead and start by creating the layer script that'll allow us to set all of these graphics and control the different things like colors and the appearance of the character. This is just going to be a new script called a character sprite layer or something like that. So all the layer is it's just going to be something attached to the character that controls the way they appear. For our body, our eyes, our outfits, whatever may go on this particular layer. We'll be able to set whatever image goes on there, whatever color, and whatever else you can do with those specific images, like highlight and darken to show who's active and speaking in the scene. We'll do that through character layers. But first of all, we don't need start and update, and we don't need mono behavior either. What we do want is we want to put this inside of a namespace, and we should already have one for our character's namespace, so if we just type that in, then we have this where it needs to be. So for our layers, we want to keep track of a couple things. I'd like to have the number of the layer, so I'm going to make a public integer, just so that way we can retrieve it from outside if we need to, and we'll have a getter and a private setter. And just default this to 0 for the time being. And we want to know what our active renderer is. What's the image that we have showing the graphic for this character? So let's make sure that we include that. And we also need the Unity Engine UI namespace for that. So we'll have our image, we'll call that the renderer. And again, this will be get and private set. And we'll default that to null as well. In addition to the active renderer, we also want to have a list of any inactive renderers that are currently transitioning out. Because when we change the graphic for a character, we don't just want to plop it on screen. It'd be nice if we can fade the old one or the old ones out and fade in the new renderer. So we'll want a list for that. But we don't need to cache the image component for the old renderers. All we need is the canvas group that we applied to the layer previously, because the only thing we need to change on an old renderer is the alpha value. So let's go ahead and make a private list. There's no reason to have this external. And just populate this with some canvas groups. And we'll call that the old renderers. And to make it easy on ourselves to fade in our image as well, let's go ahead and make a pointer for the canvas group that's applied to whatever our active renderer is. One more thing that we want is we want a reference to the character manager in the scene, because we won't be able to run our coroutines on this layer without a mono behavior, so let's also make sure that we have a quick reference to the character manager. Okay, and with that, we're ready to continue. The way we're going to get these layers is we're going to have them created by our sprite character on start. So whenever we create our sprite character, it's going to go through and find the layers that we've given to this character, and then create a sprite layer for each layer. So we'll go ahead and make ourselves a constructor for that to make it easy to add each layer for this character. And we'll pass in whatever renderer is going to be the active renderer. So we'll call this the default renderer. And we'll also pass whatever layer this is supposed to be on. So this might be layer, we'll default that to 0. And when we come in here, let's go ahead and set that layer that we made a second ago, the integer cache, to whatever the layer is we're passing in. That way, we've already got it. And let's make sure that we set our renderer to the default renderer. And that will allow us to create each layer for our characters. Now, speaking of our sprite character, let's go ahead and actually create the layers. Let's make a separate function, a private void called getLayers, which will grab all of these for us. And once we create the character, let's go ahead and get the layers as well. Okay, so in here, all we need to do is evaluate whatever our prefab looks like. So let's hop back into Unity and take a look at it for a second. So if we take a look at Stella here, we have the root character object, and then we have an animator right beneath her. So that's the first child element. And the animator has a child called renderers, which has the renderers for our character. So we want to make sure that we look under the animator for this character, find this renderers object, and then get all of the images that are assigned to it. Just in case you want to call that root object something other than renderers, let's go ahead and make a constant to define what that is. So let's go ahead and see what we can get. Let's get the transform of that object. Let's cache it in a transform field called renderer root and set that to our animator.transform.find. Let's find the child of that name. Now, if for some reason we don't have that renderer root, let's just go ahead and return and do nothing. But if we do, then let's go ahead and loop through all of the children and find the renderers that are attached to them. Okay, so we just do a simple loop and then find each child of this root object. And then we want to see if it's got an image on it. Let's go ahead and make sure that we're using the Unity engine.ui namespace, and then see if there's an image on this child. So let's get image, so renderer image equals child.getComponent image. And let's check if that's null. And let's not use try get component. Let's do it this way because there's a particular reason I'm doing that here, and you'll see shortly. So let's see if the renderer image is not equal to null. And if it's not, then we have ourselves a layer. So let's make the character sprite layer, call it our layer, and set that equal to a new character sprite layer, which takes in the renderer image and the layer that we're working on, which would be I. And then we need to add this to the layers of our character, but we currently don't have that, so let's just make ourselves a list up here for all of our layers. So public list character sprite layer layers equals, there we are, and then say layers.add layer. And so I can see this working. I'm going to go ahead and actually rename the child object by setting child.name to equal layer followed by the layer that I'm working on, the layer number. So by calling this, we should go ahead and see the layers get added to our character. And sure enough, if we run in Unity, then we can see it gets the layers for Aileen, gets layer 0 and layer 1, does the same thing for the guard, and all of the characters. So they're all getting their appropriate layers. And even better, if we run this through the Visual Studio debugger, we can see that for our character Raylene, in the layers we get a count of 2, and it does indeed get all of the layers attached to her. Okay, great. So we've got our layers, but without something to do on them, it doesn't exactly do us much good. So let's go ahead and apply an image to our character. In our sprite character, let's just make a new function called setSprite. Make the public void and just call it setSprite. And we're going to take a sprite as a parameter and also the layer that we want to apply it to. We'll set that to 0 as a default. In case we're working with single layer characters, that'll make it easy to just automatically default to layer 0, which would be their only layer. And so then let's make the same function on our actual layer. In here, let's come and make another public void called setSprite. Pass in the sprite. And if we call this function, then let's make sure our renderer.sprite equals the sprite that we've passed in. So for our character, when we use this command, let's go ahead and grab the layer and our layers by that layer number and call the setSprite command and pass in the sprite that we want to apply. And on top of that, let's make a way for us to actually grab the sprite for the particular character that we're working with. That way we can load sprites by name and from different textures that are defined within that character folder. So in Stella, for instance, in her images folder, we've got all these different sprites, and I want to be able to load them based off of the name here. Like we have default 4 and laugh 4 and then the body 3, 4, 2, all of that. I want to be able to load those easily. And also for Raylene, I want to be able to enter this sprite sheet and grab any one of these that I want, right from the character class. In order for us to do that, we're going to need to know the location of that images folder, which means we're going to need to know the actual folder path within resources. And when we're creating the character in our character manager, if we come down to where we're getting the character info, we're grabbing the prefab in get prefab for character, and what it's doing is it's taking the path, formatting it, and then just loading the prefab from that path. But then we're kind of discarding the path and not doing anything else with it. What would be more handy is if we go ahead and just get that path and then pass it into the character that we're creating as an asset directory for that particular character. That way we can access things that are defined for a sprite character or a live 2D character, like animations and images, just based off of that path and any modifications that we want to make when the character is created. Like if we create our character sprite, we can take the default path and just tack on images to it, and then we have the location for all of their images. We could do the same thing for live 2D and model 3D with whatever sort of assets that we'll be including in there. So let's make sure that we also pass that in to our characters as well. I'm going to come into our character info here and make a new string for the root character folder. And when we're creating our info, our result is going to just take our path. So result.root character folder equals the format character path with our character root path format, and then inject the character name into it. And that will allow us to go ahead and pass that into these characters that we're making. So I'm also going to add info.root character folder, and we'll get an error because that's not included right now, but I'm going to do the same thing for our other types too, and then just correct them. So in our character sprite here, let's make another variable for the string called the root assets folder. And the same thing for live 2D. And model 3D as well. And what that will allow us to do is to define the location for all of our images for this sprite character. So let's make ourselves a new private string for the art assets directory. And when we create the character, let's go ahead and say art assets directory equals the root assets folder plus the location, which would be /images. Just running the debug test and looking at the root assets folder, I do need to set it as the character casting name, because if we're casting, then it's going to get this instead of just generic, which is what we want. Let's quickly change that, go into Character Manager, and make sure that when we're getting the root path, we're instead of character name, it's going to be result.castingName. And now with that, if we take a look at our assets directory in the debugger here, we can see it's characters generic images. Let's go ahead and continue to the next character that's created. Take a look at that, character Raylene images. So that's working as it should be. And so now that we have our art directory, we can go ahead and get the sprite that we want too. So under set sprite, let's make ourselves another function called public with a sprite return type called getSprite. What this function is going to be looking for is the name of a sprite. So sprite name will do. And it's going to be different depending on what the type of our character is. If it's a sprite character versus sprite sheet. So let's evaluate that real quick. If config.character type equals the character type dot sprite sheet, then we'll do one thing, otherwise we're going to do another. Let's start simple, and if we're just a sprite character, then all we're going to do is we're going to return something returned from resources. So resources.load, we're going to load it as a sprite, and the path that we're going to look for is going to be our art assets directory with another slash and the sprite name that we're trying to load. Right now, let's go ahead and return null to satisfy the function there. And let's test this out real quick. In the test character script, I've got all this stuff rolling. Let's go ahead, before we do all of this stuff, I'm going to insert some text here and say, first of all, let's get a sprite. So sprite, Stella sprite equals Stella, but I need to get her as a sprite character. The get sprite is not going to be available on the base character class because that's obviously specific to the sprite character. So let's change this from character to character sprite, and then just end this with as character sprite. So cast it to the appropriate type. And now we can say stella.getSprite, and I want to get her body position 3. So I'll make this the body sprite, and I'll do one more for the face sprite. And that face sprite is going to be laugh 3. And to apply these, all I need to do is say stella.setSprite and provide the body sprite on layer 0, and then stella.setSprite for her face sprite on the layer for her face, which is 1. And when I roll that in Unity, we can see that she has her appropriate expressions there. And so if I then wanted to wait 2 seconds and then set her to an angry expression, we should be able to see that change as well. We should be able to see that and give a clearer view of the changing of the sprites here. So 1, 2, there we go, it changed. So that's half of it. Now we need to do the same thing for our sprite sheet character. I'm going to remove all of this because that's beginning to look like a mess. I just want to clean it up a little bit. And I'm going to do the same thing for Raylene and get her as a character sprite instead of just the regular base character type. And I may as well do the same thing for the guard here because making him generic is technically making him a sprite character. And we'll want to test the feature out on that guy as well. So for the sprite sheet characters, it's much different. First of all, if we're just loading it for a regular sprite character, then it's just going to be loading an image. And that is going to be straight within the images directory. But if we're trying to load a sprite sheet character, then not only does it need to load the sprite from a particular sheet, but it needs to know the name of that sheet. We could have multiple textures assigned, so we'll technically need to pass in 2 values here. But we'll do it in a way where we format it with just a little dash in between the texture name and the sprite. That way we can throw it all in there. That way we can pass in a texture name and a sprite on that texture and get the appropriate one. If we look in Raylene, what I mean is we have this texture, and then we have these individually named sprites, which actually I did not name these, they're just numbered. Let me do that real quick. In case you want to know how to do that, we go into our sprite editor, and then just select whatever sprite it is you want. You can come down to the name here, and then change it to something that fits. We're going to do something simple, and for this one, it's going to be A1. For this one, A2, and this pose will be B1, and that one will be B2. And then I can come down to these different faces and set them to match the body. So this one here would match A, so I'm going to do A and then a description of it, like scold or something. And then this one's for the B body position, so I'll do B scold. After renaming them, I've got all these sprites, and I would then load them by whatever these names are to get the expression. But I'd first have to reference this sheet. So if I wanted to get that, then when I call get sprite, it would be something like Raylene-A1, and that would get me the texture and the sprite from that texture. One way to make this easy on yourself is you can just label the image the name of the character, and then if you don't specify a texture name, then we can just automatically grab whatever texture is called the name of that character. Or you could change this to something like default, and then if we don't have a texture name, then it's automatically going to look for one that's called default and load the appropriate sprite, which I think that's how I'm going to do it here. So I'm going to do the same thing in generic, and these guys are not named either, so let me go in and change that. I honestly can't tell a difference between these two guys, so I'm going to delete that one, and I'm just going to have these 4 characters. I'm going to call this guy a monk, this one girl, this one man, and that one the guard. There we are, and then I'll rename this one to default as well, since that's the only texture in this folder. Since I'm calling mine default and I'm not using the character name, I'm just going to make a constant up here where that I can reference for that name. So this is going to be the default sprite sheet texture name. And I'll call that default. And I'm also going to make another one for a private constant character, and this one's going to be the sprite sheet texture sprite delimiter, and that's just going to be a little dash. That's what would separate my texture name from the sprite name if I were going to use that. And I'm just going to rename this one. I don't like that. I'm going to name it sprite sheet, be consistent with the other one, and call it default sheet name. Alright, so we got those two. Now let's go back to our getSprite function and make this work. So the first thing we want to do is we want to try to split our sprite name just in case we're passing in a texture and a sprite. So let's make a string array to hold our data, and that'll equal the sprite name dot split, and we're going to split by the delimiter. Now let's evaluate if we had a texture and a sprite. We can do that just by checking the length of the data. If data.length equals 2, then we know that we have a texture and a sprite name. Else, we know that all we have is the sprite name. So in this case, we can go ahead and get all of the sprites from the default texture, which will be the default sprite array. And this is going to be resources, but instead of load, we're going to use load all to get all of the sprites from the texture that we're using. We'll do this like we did below. Specify our art assets directory, and inside of there, we want to specify the sprite sheet default sheet name. So this will get us every single sprite in the texture. Now, just in case we don't have that texture, let's make sure we log ourselves a warning. So if default sprite array dot length equals 0, then it didn't find a texture and we don't have anything, or we didn't import it right, and we'll log a warning. So if we don't have it, I'll just say that this particular character does not have the default asset, and then I can go and fix it if I need it. Now, if we do have this texture, then we want to go ahead and return whatever sprite it is we're looking for inside of that array. And we can do that through returning, and we need the system namespace to call this array class. From that class, we call find, and we're going to find the sprite. So we're going to do a little evaluation, passing in our default sprite array. And then our evaluation is going to be on the sprite, each one inside of this array, as long as the sprite.name equals the sprite name that we're looking for. So if we have the texture and we have the sprite, we're going to go ahead and get it that way. On the other hand, if we did specify a texture, then let's go ahead and try to load the array from that particular texture. So let's make a string to get that texture name, and that's just going to equal data at index 0, And then we can just change our sprite name to equal data1. So let's load that sprite array. We can go ahead and copy this line, paste it there, and instead of here, we're going to get our texture name. I'm also going to grab the same warning here and throw it just in case we don't have the texture that I'm looking for. I'm going to say character does not have an art asset called the texture name that I'm trying to load. But if I do, let's go ahead and return array.find for the default sprite array. We actually change that to sprite array because that's not the default one anymore. Let's look for the sprite as long as the sprite.name equals the sprite name. So doing this, we should be able to either reference the default texture for the character and pull out the sprite from that, or reference a different texture, such as maybe for a different layer or outfit, and then grab the sprite from that texture. And we can test that here by saying sprite s1 equals, let's go ahead and load the guard first. Guard.getSprite, and let's get the monk sprite. So this should load the default sprite for monk, and then say guard.setSprite to s1. So we'll set the sprite on the default layer from the default texture, grabbing monk. As long as we do that, we should look for the default texture here and look for the image called monk, and then set it to our guard. Let's see if that works here. Should work. Raylene is showing up. Let me swap Raylene for guard. Now, to make this easier on myself, with all this testing I'm doing, I don't just want to say show all the time for the character. I'm instead going to make a constant up here, which I'll be using to toggle whether I want characters to appear on start or not. So, a public constant boolean called enable on start. I'm just going to set that to true right now. And then the character sprite, I'm going to evaluate that. So it'll be equal if in character enable on start. If we're enabling on start, then the starting alpha is going to be 1, otherwise it's going to be 0. And actually, I can just remove that because it's part of the same class. So if enable on start, root alpha is 1. If not, alpha is 0. And we run this in Unity, we can see that our guard spawns, but he's using the monk sprite because it pulled it from the default asset and applied the image. If, say, we had a different image, then I could call this maybe characters, like this was a separate image from something I was trying to load. And then instead of just loading monk, I'll say characters followed by the delimiter that I made. So loading the texture of characters and the sprite called monk. And it's able to interpret the texture as well as the sprite. And if this is not intuitive for you, feel free to change that up to whatever you'd like. Maybe you could have, like, identify text patterns. Like, you could specify text for characters and then, like, something for sprite for the monk, and then find whatever is being applied in the string, or make them separate parameters. It's really up to you. But for me, I'm just going to keep it simple, and I'm just going to make it a little dash delimiter. Now, one thing we'll notice is if I log a message for checking if my guard is visible or not, using the enable on start right now, when he's created and visible in the scene, we can see it still says visible is false, and we just need to override this from the default character type. So the default character type is setting this is visible to false automatically because technically a text character or any other character is not going to be visible unless we tell it what it's looking for. So for the sprite character in particular, we can override that by saying public override boolean is visible, and then we can evaluate this. And we can either do one of two things. We can check if we are revealing, so if we're revealing, we know the character's visible, or we can check and see root.cg, or rootcg rather, dot, one of these days I'll get it right, dot alpha equals 1. So if we're fully visible or we're revealing, then we know our character is visible, for the sprite character anyway. And like that, when we create the character, we can now see visible is true. But if I were to change enable on start to false, then with him not on screen, we can see visible is false. Okay, now would be a good time to just refactor this function just a little bit because we got some repeat code here, and that's the last thing we want. So in this check, all we need to do is just grab whatever sprite array it is we're trying to find, and then the rest of this can execute outside. So I'll go ahead and remove that little bit, and I will remove this, and I'll just pop this outside of our check there, and go ahead and define my sprite array just outside of here. I'm just going to call that sprite array and say is equal to a new sprite array of just 0. And so then I'll simply just access it there, and then change this one to sprite array, and change these values. Whoops. Change these values. Just like that. Now we're not using any repeat code, cleans it up a little bit. And running it in Unity, we still have no issues because the code is just functioning the same way. Okay, fantastic. So now we are able to set our sprites. We're able to get our sprites, but the next thing that we need to do is we need to transition over time to a new sprite. We'll do this directly through our character layers, but we're going to need to call the coroutine through the character class itself, or the character sprite class in this case. So in our character sprite class, underneath getSprite, let's go ahead and make a new function. And this one's going to be public, and we're going to return a coroutine, as usual, and we'll call this transition sprite. The whole purpose of this function is to gradually change the image on one of our layers, or multiple layers at a time. So we'll stick with just doing this call per layer. So we'll specify the layer, and we'll specify the sprite that we want to change to, as well as the speed. So let's go ahead and define the sprite that we want to use. And let's specify the layer, just in case we're a single layer character, default it to 0 to make that easier for us. And then make a speed, which will also default to 1. And inside of here, what we're going to need to do is we're going to need to access the layer, and then we're going to need to return a coroutine that is running on that layer. So real quick, let's go ahead and grab the character sprite layer and call this the sprite layer and set that equal to our layers at whatever layer it is that we are trying to access. And then we need to call some kind of coroutine on it. So let's control click and enter that real quick, and now let's make the logic so that way we can actually transition one of these layers to a new image. First thing we'll do, like usual, we want to make sure that we keep track of whatever coroutine is running on this character. So let's make ourselves a private coroutine called co transitioning, and then we can make ourselves a boolean, public bool called is transitioning layer, and report that true if our coroutine is not null. This is extremely important. Let me just stop and notify why we are doing this for every single coroutine that we're running. So we have all these different functions that can run over time for characters. They can move, they'll be able to change colors, to change their layers. Anything that is running over time is an action on a character that we need to keep track of, because we need to ensure that we're always canceling out ones that are no longer valid, so they don't start like with layering coroutines on top of each other if we call more than one at a time. For instance, with visual novels, what people will do, you have to plan for it, is they're going to skip a lot of dialogue. They're going to skip a lot of scenes, like maybe they want to catch up to a certain point, and so they're going to play all these lines super quick. And so you're going to have calls for coroutines just running one after the next in this sort of, I guess, worst case scenario. So by keeping track of it and enforcing this coroutine to be the only one that's active, we can ensure that we're not going to have any issues down the line with skipping lines and skipping and running so much logic just one after the next. So that's why we're doing this for every single coroutine that we're making. But now here, let's go ahead and define our our coroutine. So let's make the function that's going to start it. So we'll make a public, give it a coroutine return type, and call this transition sprite. And inside of here, let's go ahead and supply the sprite that we want, as well as the speed that we want to apply it at. We don't want to start a new coroutine if we're already set to whatever sprite we're trying to transition to, obviously. So if sprite equals our current renderer.sprite, then what we want to do is just go ahead and return null. Because in that case, we're already using that sprite and we don't need to do anything. So next we need to see if we're already transitioning. So if is transitioning layer, then we want to make sure that we stop it. And we'll be running this on the character manager. So let's grab character manager dot stop coroutine, and we will stop the CO transitioning layer, which we'll use to store the coroutine. And then let's go ahead and assign it if we've made it this far. CO transitioning layer equals character manager dot start coroutine, and we're going to start this. Let's make it private, enumerator, and we'll call it transitioning sprite. Again, taking in the sprite that we want, and the float for our speed multiplier. And so when we start a coroutine, we're going to be starting transitioning sprite, passing in our sprite, and our speed. And then, of course, return CO transitioning layer, which means in our character sprite, after we get our layer, then we can go ahead and call that function. And that'll be simple as return the sprite layer dot transition sprite, passing in our sprite and our speed. There we go. Okay, so for our coroutine, here's what we need to do. Since we've only got one renderer, the first thing we need to do is we need to create a new renderer, which means a new image in the UI. And that way we can add our current one to the old renderers list and make this new image, the current renderer, apply the sprite, and then bring it in on full alpha. So let's make ourselves a function to make this easy on ourselves and create a new renderer through this function. We'll give it private, have it return the image type since that's what our renderers are, and call it create renderer. And in here, let's specify the parent for this object. So transform parent, and this would be the layer object that's holding the image. So let's start by saying image new renderer equals object.instantiate, and we want to instantiate a copy of our renderer and parent it to the parent. That parent is going to be whatever the root object for this renderer is going to be, which in our case is that one object called renderers, but we'll actually change that in a minute and I'll show you why. But for the time being, since we have this in place, we can go ahead and say image new renderer equals create renderer, and let's pass in our renderer.transform.parent. So now that we've created a new renderer, let's go ahead and access our old renderers and add our current renderer. We have to do the renderer CG because the old renderers are using the canvas groups and not the images. Just makes it easier for accessing the value. And now we need to set the new renderer sprite and initialize its alpha to 0, that way it can fade in. So our new renderer, let's go ahead and set its name and set it to the renderer.name, so it's a copy. And that way we don't have the clone name getting stacked on top of it. And the next thing we want to do is assign our renderer to equal the new renderer. So now this is our new renderer, and let's make sure that it's active in the scene. So renderer.gameObject.setActive true. And go ahead and say renderer cg.alpha equals 0. That way it'll start invisible and we can fade it in. And now let's return the new renderer, which would actually be renderer, so if you don't want to return it, you don't have to, but I find it, I'm just going to go ahead and return it. You could just say create renderer, and then you've got access to your new renderer without even needing to return something. But I'm going to return it and just make it like that, because that's how I roll. So we've created our new renderer. Now let's make sure it's using the right sprite. So new renderer.sprite equals sprite. And now all we need to do is just start fading it in. So we need to make another coroutine, which is going to fade in our active renderer and fade out all of the old renderers. Let's go ahead and return null right now, just so we don't have an error on this coroutine here. And we need to make a new one. This one I'm going to call alpha leveling. So we're going to try to start a coroutine to level our alphas. If we want to keep track of that, we're going to make ourselves another coroutine. So private coroutine co leveling alpha equals a null. Public bool is leveling alphas. Okay, so we're keeping track of that. And now let's try to start it. So private coroutine try start leveling alphas. We're only going to start it if we're not already running an alpha leveling coroutine. So let's check real quick. If is leveling alpha, then just go ahead and return the coroutine that's already active and running. Otherwise, co leveling alpha equals manager or equals character manager dot start coroutine, and this is going to be a coroutine called leveling alphas. And this is going to be a coroutine called run alpha leveling. Let's make a private I enumerator just for that. So run alpha leveling. Okay, so the coroutine we're going to start is then run alpha leveling. And we can just return co leveling alpha. Now what we're going to be checking for in this coroutine is just any one of the images for this layer, checking if the current one needs to fade in or if any of the old ones still need to fade out. So let's run a while check and check our renderer CG first. Let's check the alpha and see if it's less than 1. If it is, we know that we need to continue this loop. Or let's check our old renderers and try to look for anything, which is going to need the system.link namespace. So old renderers.any, and we'll represent each one in this list as old CG, and then run this expression on it for old CG.alpha is greater than 0. So if our current renderer is not fully visible, or if any of the old renderers are still visible, then we want to run this loop. We're not going to be using any smoothing here, it's just going to be straight up math.moveTowards, because there's no need to smooth this. It already looks fine without the need for that. So all we're going to start with is rendererCG.alpha and say that this is equal to mathf.moveTowards a target. Of course, starting with rendererCG.alpha as our starting value, and we want to move this to 1, that way it fades in. And we're going to want to fade in by some kind of speed. How about we go to the top and define ourselves a default speed? So I'll make a private constant float called default transition speed. And I'm going to set this equal to a value like 3. And I'm also going to make a little multiplier as well. So a private float transition speed multiplier. And that's just going to be 1 for right now. The reason I'm including that is because we're only going to start a new alpha leveling coroutine if we don't already have one running. But if we call transition sprite, we can pass in a speed multiplier no matter what. So if we're running a speed multiplier, then we want to make sure that we update that so that way our coroutine that's running takes notice of it and uses the right speed. So from this function, before I create the new renderer, I'm going to say that transition speed multiplier equals our speed multiplier, and that way our coroutine will have access to the value. So we will move at a speed of default transition speed, and we're going to multiply this number by our speed multiplier, and then we'll multiply by time.delta time. So that's going to work on fading in our current renderer, and now we just need to do the same thing for our old renderers. We're going to start off with an integer called I, and that's going to equal our old renderers.count minus 1. And then as long as I is greater than or equal to 0, then we're going to decrease I by 1. The reason we're starting at the end of the array instead of the beginning is because anytime you're going to change or remove an item from an array, you can't do that if you're running a for loop like this, because it's going to detect a change in the array and it's going to cancel itself out. So like if you removed one, then your integer I would no longer be valid, and the code is smart enough to catch on to that. So you have to start at the end and work your way backwards if you're changing the actual variables inside or removing them. So that's what we're going to do. It's different for if you're manipulating data inside something like a float. You're just changing the data type, but you're not actually removing or reassigning the actual value field itself. So let's go ahead and start at the end and go all the way down to 0 to the first element and just fade them all out. So let's go ahead and grab our canvas group, and we'll call this old CG and set that equal to old renderers I. And now let's move that alpha down. So old CG dot alpha equals mathf dot move towards old CG dot alpha. We're going to move towards 0, and we're going to move at our default transition speed, multiplied by our speed multiplier, and multiplied by time.delta time. And to save ourselves on a little bit of math here, very minimal processing, but make optimizations wherever you may if you want. Let's go ahead and store float speed to this current value, and then we'll just transition by speed instead of performing that math calculation every time. So minor optimization there. And now here's why we wanted to start at the end of the array instead of the beginning. For anything that reaches 0 alpha, we're going to remove it. So if old CG.alpha is less than or equal to 0, it should never go less than, but force a habit of mine, then let's go ahead and do something. We'll say old renderers dot remove at I, and object dot destroy. We're going to destroy the old CG, but that's the component, not the game object. So reference the game object, and we destroy the image in the scene. Okay, cool. So let's make sure while we're in our loop that we go ahead and yield return null at the end of all of that. And then at the very end, let's go ahead and assign CO transitioning layer to equal null. That way we recognize that the coroutine has ended. So that'll control our levels, our alpha leveling. So back in create renderer, or in the transition sprite, we're just returning null here. Let's remove that. We've created our new renderer, and now let's go ahead and try start our leveling alphas. Let's try to start that, and then let's just check while is leveling alpha, then yield return null. Let's wait for it to complete. You know what, we could even do yield return try start leveling alphas, and we'll just wait for the coroutine, whether that's a new one or the active one, to finish. And once this is done, we can say CO transitioning layer equals null, and we're done. So if we hop into our test character script, then instead of set sprite, let's go ahead and transition to that sprite. And let's just yield return, wait 4 seconds, 1 right before that. So we have a 1 second delay. I need to do a new right there. Okay, so after 1 second, we're going to transition to the new sprite. Starting it up. 1 second. There we go, and we now faded to the new sprite. How about we try that with a layered character? Since we know that guard is working, I'm just going to hide that guy. And we're going to work with Raylene instead. So sprite1 is going to be Raylene. I'll make S1 the body. And let's see what Raylene has. So Raylene has images. I'm going to switch her to, how about B2? So we'll switch the body to B2. And then we'll do the face will be Raylene laugh 2. Then Raylene dot transition sprite. We're going to do the body sprite on layer 0. And then Raylene dot transition sprite for the face on layer 1. Actually, I forgot my own naming scheme. It's not laugh2, it's b_laugh. So let me change that real quick. So b_laugh, and then how about I just yield return new wait for seconds, and we're gonna wait for 1 second after that, which means yield return Raylene transition sprite, so I wait for that to finish and then wait 1 second, and then Raylene dot transition sprite to Raylene dot get sprite, and I'm going to grab the B laugh. Wait, I've already got that one. How about B scold? And let me put those in quotation marks because I'm getting way ahead of myself here. Okay, so we're going to transition to a laughing image, and then we're going to transition to a scolding facial expression. So the body will remain the same, but the face will change. So here we go. Okay, and there we go. She changed 1 Mississippi. Okay, either time stopped or my code didn't work. But this is exactly why we do testing, to find things like this that don't work. So question is, why isn't it working? How much you want to bet it's because I'm nullifying the wrong coroutine. So transitioning layer is, yeah, that's calling for alpha leveling, but that's not the coroutine itself. See, try start leveling alphas is starting CO leveling alpha, so that's the one that needs to return null. So we transition to laugh, and then, ooh, there's a part of me that just doesn't want to get this right today. Transition sprite, I need to specify that this is layer 1 instead of layer 0, because that is not supposed to go onto the body. So let's see what happens when I actually specify the layer. We changed that, and then we changed the face. Cool. So I want to run Stella now, because that's our sprite sheet character, and let's now run Stella as well. So after we bring Raylene in, we're going to go ahead and show Stella. Well, let's go ahead and do Raylene.move to position vector2.0. So she's going to move to the left of the screen. And then Stella.show. So I want Stella to be invisible on start, which means after I create Stella, let's say Stella, I want a way to set the visibility manually on start for this instance. Why don't I come into character, and instead of making this simply a getter, let's make it a getter and a setter. So then in character sprite, when I get is visible, what I'm instead going to do is I'm going to say that this is get, which will return is revealing or rootcg.alpha. And then set is going to do something. Set is going to say that rootcg.alpha equals value. If the value is true, then it's going to be 1. Otherwise, it's going to be 0. Which will allow me then to say Stella.isVisible equals false. Since they are visible by default on start, I'm just going to set her to false. And then after Raylene does her first transition, then Stella's going to show, and I'm going to yield return stella.show, then wait for a second. Raylene's going to transition her sprite, and then I want body to equal stella.getSprite, and I'm going to use the number 3 body position, and then the face equals stella.getSprite, and I'm going to get sad 3. Did I spell that right? Yeah. Okay, so that's what we'll do. And then, lastly, gotta assign them stella.transition sprite to the body, and stella.transition sprite for the face on layer 1. And at the same time, I will yield return and make Stella move to the right of the screen. Great, so she'll start invisible, and then they should both come in after Raylene does her first transition, and then we'll see them both change their layers for both sprite sheet and regular sprite character. I'll change this up slightly. I'm going to remove that yield return right there, and I'm going to cause Stella to show up, but then I'm going to cause her to move to this position. We'll wait for her to move, and then we'll take care of all the transitions. Okay, let's launch it in Unity and see what happens. Cool. Okay, so we can see that they're both working, they're both finding their sprites, and they are transitioning just like they should be. If we just come in here real quick and change the speed on Raylene's transition here, then we should see it much slower for the facial expression. And sure enough, it sure was slower. So the speed's working. So now just a little test. If we go ahead and transition her body and then transition her face, then what we get is a transition, and she looks fine, just like we've been working with. But let's just say for kicks and giggles, first of all, I'm going to yield return, wait for seconds, and I'm going to wait for 1 second. Now let's just say we switch the order of this. And so now we're transitioning the face before we transition the body. And now we wait a second, and then what happens is we have the body, but we have no face. Well, actually, we have both of them. And that's because the layers have been switched. Because it's spawning a new layer, every new one that gets created is going to be added to the bottom of the list, which gets layered on top of the other ones. Whatever's on the bottom gets shown on top. Since we called the face first, it got created in front of the body, and then we called transition on the body, which created a new one, which went over the face. So the order is not being maintained in these layers. So the best thing that we can do to fix this is create little sub-parents that hold the objects specifically for each individual layer. We've got one that holds all the renderers, but inside the renderers is each of our layers. So let's go into Raylene for a second. So if we're working in Raylene's prefab here, if we look at renderers, this is holding all of our renderers, but each one of these is its own layer. And so we want to make sure that any object created on a layer is constrained within that particular layer. It won't override any of the other ones, and it won't render on top of layers that are a higher index. So what we can do is right-click renderers here and create empty, which will create an empty game object, and we'll just call this something like layer 0, and then come over to our anchors, Control-Shift-Alt, and do the all expand. So now it's the size of the root, and we'll just parent body to layer 0, but not before we duplicate that and make it one for layer 1. So body goes on layer 0, and face goes on layer 2. So now if I were to duplicate body, it'll stay within layer 0, the constraints of that. So let's go ahead and back out of that. And let's do the same thing for our other characters. And so whenever we create a new renderer, it'll stay within its layer. But that just means we need to change one more thing in our script. When we create our character and we get the layers, we are now trying to get the image off of the actual layer container. So let's change this from getComponent to getComponent in children, and grab the image of the child object. And in test characters, I'm just going to yield for the duration of this face transition. That way we can really see this working. So we're transitioning the face first and then the body. There goes the face and the body. So what previously was getting our layers out of order is now working for our characters. Great, that's a good stopping point for this video. And the next one we're going to be working on changing the colors of our characters. And this will be useful for setting different colors for different layers, or even darkening and highlighting characters to show which one is active and speaking in the scene. So without further ado, I'm going to end this off here, and I'll see you guys in the next video.